Hello and welcome to the Data Engineering Podcast, the show about modern data management. Atlan is the metadata hub for your data ecosystem. Instead of locking your metadata into a new silo, unleash its transformative potential with Atlan's active metadata capabilities. Push information about data freshness and quality to your business intelligence, automatically scale up and down your warehouse based on usage patterns, and let the bots answer those questions in Slack so that the humans can focus on delivering real value. Go to dataengineeringpodcast.com/Atlan today, that's ATLAN, to learn more about how Atlan's active metadata platform is helping pioneering data teams like Postman, Plaid, WeWork, and Unilever achieve extraordinary things with metadata. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends at Linode. With their new managed database service, you can launch a production-ready MySQL, Postgres, or MongoDB cluster in minutes, with automated backups, 40 gigabit connections from your application hosts, and high-throughput SSDs. Go to dataengineeringpodcast.com/Linode today and get a $100 credit to launch a database, create a Kubernetes cluster, or take advantage of all of their other services. And don't forget to thank them for their continued support of this show. Your host is Tobias Macy, and today I'm interviewing Vusal Dadalov about Iomete, an open and affordable Lakehouse platform. So, Vusal, can you start by introducing yourself?
Yes, sure. Thanks, Toby, for having me here. I'm Vusal, co-founder of Iomete. Iomete is a Lakehouse platform. My background, I'm distributed system engineer. I worked in companies like Uber, Karim, OLX Group, and some telecom company in the past. Yeah, that's my background.
And do you remember how you first got started working in data?
It was probably 10 years ago, while I was working at telecom company. Since my background is distributed system engineering, that's one of the area, data infrastructure, where the distributed systems is being heavily used. I started this consulting data engineers, how to build data platforms and infrastructure. That's how I got started, and then get heavily involved over the time, and then found myself building data infrastructure many times over and over again.
As far as the Iomete project, I'm wondering if you could describe a bit about what it is that you're building and some of the story behind how you decided you wanted to create it, why you decided that this was a problem that you wanted to spend your time and focus on.
Iomete is a most affordable and open source Lakehouse platform. The reason we started this, actually, that's my previous experience. As I said, I've been involved many times building data infrastructure in the past, and I saw some, repeating problems as a customer, as a, user that we were building that infrastructure. The first thing was the big data platforms is expensive. Yeah, in the past it wasn't a problem because companies, they're only big companies. They were using big data platforms like the telecom company I worked, and they were ready pay $1 million. But as time passed, it's now more common. Data is not a expensive thing. It's a commodity now. And some platforms, there are improvements on the cost aspect, but still it's stay expensive. And yeah, we were fighting as an engineer, a builder of this infrastructure. We were always got pushed, how we can optimize, how can we make more cost efficient. Yeah, that was one reason. The world is going to data intensive. All the companies, in order to stay competitive in the market, they should use the data, and the data is becoming a usual thing. And that's why we should provide a platform that's inexpensive and reachable, accessible by everyone. That's one problem. The another one is transparency. Some vendors, we were using, I guess I can name a few, well-known names that people can easily resonate, like Snowflake. There's intransparency in that, in the storage side, because you just put your data to somewhere else in their own format, plus the compute you use, you don't know what actual compute engine they use. That they could optimize their platform, but they can still use a cheaper device, and they have higher margins. So there are a lot of intransparency there. I was wishing that, hey, I should own my own data, it shouldn't go somewhere else. And There is also really great open data formats like for analytical world, like Parquet or say this type of formats. And it should stay on my side. Then like I feel comfortable that I own my data. And whenever I don't like the vendor's service, I can switch to use different platform that will also like push the vendor provide the best service because they're not locking the customers. Yeah, behind this transparency there's also this locking stuff. Like with all this they're kind of locking the customers. Another thing is the integrations. Like I remember like every time when we build, when we say today modern data stack, their components are very well known. Like you need the ingestion, you need data analytics or processing layer, you need data governance, BI, etc. These components are well known, and this modern data stack has got matured a lot that you can identify like any company, regardless of their, like the business type, they're more or less building the same. Like most likely, if we give a name like from the well-known vendors, Fivetran the ingestion or Airbyte or similar technology. Data processing side is like Databricks, Snowflake, BigQuery, this type of product. Data governance, you need to go another vendor, like you need to bring Calibra, I don't know, Talent, like or similar platforms. And usually all these vendors, they have really great features, but like it costs a lot of engineering efforts to integrate all this stuff. Every different company in every different like building infrastructure building, you have the same components with different vendor names and doing the same integrations. And I remember at the time I was like thinking, like if you look to the world as a like our home, inside this home we are repeatedly doing the same thing, like integrating all these different pieces. Like but we can outsource, centralize this effort to some other company, and then other like we shouldn't do this repeatedly, and then we can save those resources to do something that is innovative, not just like very repetitive. So that was the idea, like hey, that's another thing like I wish to have that. Hey, like all these components are well known, like why wouldn't we have a platform that involves all this together? Because this is not rocket science. We need ingestion, we need analytics layer, we need data governance, and that's all. Like I saw like from this telecom company, like OLX Group was a big e-commerce company. Karim was like a smaller version of Karim, then like Uber, which was bought by Uber. And at Uber, so like the same, set of technologies, like the names are changing, but the concept is same. So all these things kind of like triggered me. Well, let's start with the, efficient, the cost aspect. I can give an analogy. Actually, that's some kind of coincidence. Before this podcast, I saw an interview of Figma co-founders, and their pitch was so boring. Like it was like they were asked like what's the difference than Photoshop or Adobe XD, this kind of stuff. And it's like they were like, you want to provide easy to use and inexpensive. At the time it wasn't sound like inexpensive. It's like just trying to sell inexpensive software wouldn't keep you in the market, like you will get crushed. But like 10, 12 years later they were sold for 20 billion. But it's not a good news for customers, because that's the reason customers love that. It was a time this design things got, like it becomes like a usual thing. That's why they were searching an expensive solution. I think we can have the same analogy now. Like we want to stay on that location in the map, whatever that map is, that we want to provide accessible, easy to use. And another reason we use the open source one, of course, like building this type of platforms from scratch is very hard. It's not possible. But another reason we use the open source, still like continue with the open source one, is it's the transparency aspect. Like we want to stay, hey, this is open source. We store data on customer side. We are transparent on that. We show which node you use. We are transparent on that. We don't add any markup, because since we manage whole infrastructure, our business model is to get this reserved instances from AWS and get our earnings from there, not from the customer, blah, blah. Like we are trying to solve all this with this model. And integration wise, we built the most of it, but our vision is to provide all-in-one platform. We have data governance in place, authorization, analytics layer, at some extent ingestion part. We're working towards to have like all-in-one, affordable, easy to use platform for customers. Sorry if this became very long introduction, but yeah, that's how I can summarize what we do.
No, absolutely. There are a lot of different pieces that go into building a system like this. And a lot of people will say, oh, I just need a Lakehouse, so I'll just use Spark or Trino. And then you start digging into it and realizing, oh, I actually need these other half dozen capabilities, as you mentioned. And I mean, the same thing if you say, oh, I just need a data warehouse, so I'll choose Snowflake. And oh, now I actually need governance and a data catalog and all these other pieces. And oh, it wasn't as simple or as inexpensive as I thought it was because I forgot about everything else that goes into it. And to the point of the kind of selection criteria, the core of Iomete is this principle of the Lakehouse architecture, Lakehouse platform. You brought up the topic of the modern data stack, which has been oriented around kind of the disaggregation of these discrete capabilities, and a lot of the focus and center of gravity for the modern data stack has been these cloud data warehouses, so Snowflake, BigQuery, Redshift, et cetera. And the Lakehouse architecture is a bit of a response to kind of that, the popularity of those systems, because of the fact that Lakehouse or the data warehouse is where all of your data is stored. It becomes, that center of gravity, and it becomes one of the most impactful choices that you can make as you're designing your data platform, because that impacts all of the other integrations that you're able to select from, where if you're using Snowflake, there's a fairly large ecosystem of tools and plugins to be able to work with that because they've invested in building that ecosystem around themselves. Whereas if you're building around the open data lake / Lakehouse, again, depending on whether you're using Spark or Trino or Presto or what have you, you're going to have a highly variable experience as far as the level of integration and the level of off-the-shelf pieces you can use. And I'm wondering what you see as the largest motivating factors that push people into that Lakehouse architecture, even knowing the fact that they're not going to have as easy of a time as if they were to just say, buy Snowflake or buy BigQuery.
In general, I think the cost aspect, like Databricks are also pushing the Lakehouse architecture. The integration wise, they're also behind Snowflake, what Snowflake provides. In our case, we don't have, our integration in the ecosystem is not at the Snowflake level, which is, also our customers don't expect that we are at that level. But what we give them instead of that, eventually we'll provide richer ecosystem, but we provide, they can save 5 to 10 times of their costs, like going with us. Plus, the data is stored on their account. It's stored in a Parquet format that gives additional confidence that, hey, like this company, they can only serve us better because otherwise we would go. That's also like good for us, that keep us healthy. Like we know that we close the deal, they move 10 terabytes or like 100 terabytes of data, and then it's not done. We have to keep serving well. And we have data governance and other, like Spark jobs, which is not, they have Snowparks in the Snowflake case, but, I doubt that it's going to hit the same maturity that Spark has. But, like take this additional stuff that's not in the Snowflake, or there are like some features like Snowpipe, which is not a feature. That's just their shortcoming of that. They don't have Spark streaming kind of platform. That's why they build this feature in order to, provide some way to move the files, the data that's in the files. Anyway, the integration wise, we are a little behind. And open source one like Spark, you can build your own data lakehouse. Like back to your question, like in 15 minutes, maybe in a day. The problem, that's where the open source platforms are good. Like you can use Spark or Trino, and then you put Apache Iceberg on top of that to get this asset transactions, etc. But that's the main problem that you explained, the ecosystem integrations, that's not there. And plus the open source products, they're good, but they're not enterprise ready. They don't have authentication layer, authorization layer. They don't have like good UI that you manage all these things, manage your users, blah, blah, all these things. But yeah, we are building that. We released 2 months ago DBT adapter, which is like huge stuff, like because, like all engineers are loving DBT. They do all this SQL-based transformation, and DBT now support data frame-based transformations too. Like we are working to integrate that too. On the ingestion side, like we open a pull request to Airbyte for Airbyte integration. There is a Singer also, like which is backed by Meltano. We also finished that integration. That's kind of like vendors, they have open source versions. Now we are starting the closed source vendors, which is like Fivetran. The data ingestion is important because if you don't have easy data ingestion, then you won't have data inside your platform, and then your customers won't use you. And on the user side, we support all the mainstream BI tools. And I can say, like, integration wise, the customers won't miss a lot, like compared to Snowflake. That we cover all the mainstream integrations. Yeah, but probably there'll be some, nuances they could miss. But the open source ones, they will definitely miss all those stuff. They have to build what we are building for last 2.5 years. They want to build that kind of platforms in-house.
To your point of the work that you're doing to build it, and if somebody says, I'm just going to pull all of the off-the-shelf open source projects and integrate it on my own, what are some of the hidden difficulties and incompatibilities that they're likely to run into, and some of the things that you've come up against in the process of building out this fully integrated platform in the shape of Iomete?
Few stuff I mentioned, like gain authentication, authorization layer, like building some interface around this. And I think most difficult part is the infrastructure part. Like the Spark, it's good, like, but it has 1,000 different variables. Like you have to, like get the right values for you. And also infrastructure wise, where you're going to run it, like you're gonna run on the just plain virtual machines or like in the Kubernetes area, how you going to handle the scale out, scale down. Spark has its own scheduler, how it's going to work with the Kubernetes scheduler. Are you going to use the standard scheduler or are you going to use a custom scheduler? There are like lots of nitty gritty details. Like I can give a few examples. Like just one is like once you run some time, like you realize, oh, you have to run all your cluster nodes in the same AZ because cross AZ charges a lot. We are caring this because we are trying to optimize all these cost aspects for multiple customers. It's not only, for us. That's why we care this kind of nuances a lot. But like if you're building this type of platform just for your own business, which is not your core of your business, then you wouldn't care all these details. But it costs a lot, like cross AZ charge. And another aspect, like normally when they install, I've seen this many times because I did that too. And I realized later, like we didn't do too much cost optimization, but we do now because, we care about like reducing the cost as much as possible. The one thing, like when you just install run, like using S3, it goes through public internet. And like since you're gonna put all your nodes in the private subnet, it should go through net gateway, right? And net also charges a lot. But there is a specific service in S3 in AWS that it's called S3 interface gateway. You configure that, and then it goes in the backbone network of AWS S3, which like removes the charge. Like since it doesn't go through the net, you don't have that charge, and plus you stay compatible with the compliances because you don't cross through the public internet, and that service doesn't have any additional charges. Like all these small things, if you're a new company and building this, you will only notice after you get like huge bill. Like this is, like learning from the mistakes we did before. But there are a lot of this kind of problems, especially on the like handling auto scaling. It's now a huge problem. Like we still fighting with that.
Prefect is the data flow automation platform for the modern data stack, empowering data practitioners to build, run, and monitor robust pipelines at scale. Guided by the principle that the orchestrator shouldn't get in your way, Prefect is the only tool of its kind to offer the flexibility to write workflows as code. Prefect specializes in gluing together the disparate pieces of a pipeline and integrating with modern distributed compute libraries to bring power where you need it, when you need it. Trusted by thousands of organizations and supported by over 20,000 community members, Prefect powers over 100 million business-critical tasks a month. For more information on Prefect, go to dataengineeringpodcast.com/prefect today. That's PREFECT. As far as the kind of Lakehouse architecture paradigm, we've discussed a bit about some of the challenges in the ecosystem and the integration capabilities, but from the kind of processing and storage and optimization and just kind of basic functionality layer, what are some of the shortcomings that you see in how Lakehouses are able to operate as compared with a fully integrated data warehouse architecture?
The shortcomings probably, I can say right now, sub-second latency queries or point lookup queries. And also, like, there's problems like if you want to do real-time ingestion or real-time analytics, because like there's small files issues. That's famous, I think, in every data lakehouse platforms. We do have a way to optimize that, but we recommend not to ingest data like lower than 15 minutes. I think in many cases that's acceptable, but world is moving. Like there is this analytics needs. For reporting, you like 15 minutes is more than enough. But there is also real time needs. That should be a different technology. But like people are like, hey, if you have this platform, can't we have like both real time and analytics needs run on the same platform? That's why like it's converging. But right now the Lakehouse has this shortcomings, this small files, etc., that kind of like preventing that happen soon, but it's going to happen. In the traditional data warehouses, that's not a problem because the file structured in different way. That's why they don't have these problems, but they have other problems.
Digging more into the kind of Lakehouse functionality and capabilities, you mentioned things like governance, the transformation layer. I'm wondering if you can talk to some of the decision process that you went through of which pieces were, I guess, mature enough to want to incorporate into the Iomete platform and which pieces you decided were worth the effort of building from the ground up, and some of the kind of build versus buy decision that goes into building a platform like Iomete versus if you were to do it in-house for your own company.
I think first, when you choose vendor like build versus buy, most of the time we do this for our own company too. Like we should go with the buy because like with the like sensible buy option, not any buy, because if that's not the core of your business, like building a platform would cost you more than like just buying and paying someone else, because that's already centralized, that building cost in that company. But if that's your core of business, let's say if you're a data company, like for us, like imagine like we are buying a service from Snowflake and then selling that service, that wouldn't make sense for us, right? Or if we are providing ELT, ETL type of service, it's again like we should build it because that's core of our business. Also, like for companies that I think even like if they assume that they're gonna like big like Facebook, Google at Uber level, at the beginning it would make sense to buy because like to save the initial building cost, saving the hiring or maintaining this data engineers resources. At the beginning that would make sense. Then like once they get bigger, they can evaluate the situation, like having internal team and building everything in house. If that make them like more cost efficient, that's the time I think to decide that. But I think most of companies won't need that. Even like there is a bigger companies like banks, insurance companies, since they don't have enough know-how or like enough team or since that's not their core of business, they're not very, interested about like having that type of team, even though that's going to be cost efficient having team internally. They're just, buying the platform and paying someone as basically outsourcing the job. As an engineer, like I'm also, if I speak from the engineering perspective, most of the time, like that happened to me a few times. You start with the open source one, but at some point you got frustrated because many open source platforms are designed in a way that it should frustrate you. And then like you should go after the vendor, like, can you give me, ready to use, platform? Also, like sometimes you have problems, but you don't have enough, resources to fix those bugs. And that's why like after some time later you realize, oh, it would be nice to, rely some vendor to, like ask your problems, to fix some, urgent bugs, etc. Yeah, I think most of the time in today's world it makes sense, mostly buy versus build your own.
So, digging more into the Iomete platform itself, I'm wondering if you can talk to the architecture that you have built around. You already mentioned that you're using Spark as sort of the core of it, but I'm curious if you can talk to kind of the overall implementation and some of the pieces that you decided you wanted to build from scratch because it either was not cost effective to run it as is off the shelf or just because it was completely missing from the ecosystem.
The core is Spark, Apache Spark, and Iceberg. We are also planning to support Apache Hudi Delta. But besides that, yeah, of course, that we cannot build platform without leveraging these open source platforms because, that's a huge part of it. But there are other parts like data catalog. We evaluated many platforms like Amundsen from Lyft. Yeah, there are many products that I don't remember right now. I've used also data catalog at Uber. We have that experience. The other engineer that we started working together from Google, he brought his own experience from different companies, of course, from the Google too. Like we put all this, like features and how we want to see the platform. Many of those things are actually implemented at Amundsen. But, since open source product, many of those are built more generic way, like trying to support many platforms, not only Spark. Try to support other platforms too. That's why their code base it's grown huge, and also like from our perspective, it's like not easy maintainable. Like in that type of situations, we decided to build our own. Like we built data catalog, data governance, tagging, all those stuff in house, like SQL editor. Like we also evaluated some open source one, like the famous one is Hue, Apache Hue, which is like has a really nice UI, but it's extremely heavy and code base is like like it's total mess. It doesn't work like, and it doesn't have multi-tenancy. We have to like start a new separate code or node for different customers. That's also another area that we have to build our own authorization layer. There is no good authorization for Spark. We have to build everything in house. And we had a very, like bold ideas. Like we saw in previous companies how important having the fine grained authorization service. Usually the other vendors, they don't also provide, you have to get another vendor. We didn't want to involve another vendor just for authorization use case. That's why we build like table, column level, even like data masking. Everything is managed from a single place using policy rules, which is very, like we put a lot of effort on that because as a users, we have seen many times how important that are. That's something we also like built in-house, like in Spark. There is serverless Spark that we use Apache EMR before Databricks. EMR was like the lowest cost one, but the UI is not great, somehow archaic. Databricks, it's also like not talking. It's talking to like deep technical people. Not there's user interface was not that user friendly. That's why we took a little bit different approach, which is very minimalistic UI. because it comes all the sensible default values. But like for the experienced users, you can, like go to the details and then like tweak all the different attributes. But usually for like even non-Spark users can easily just deploy their Spark jobs and schedule how frequently they want to run it. All these parts like are being developed from the scratch, but the main engine, Spark and Apache Iceberg, which could take more than 10 years, you don't have a choice. You have to take the ready open source solution.
In terms of the selection of Spark as the core, I'm curious what you see as the relative strengths of that from a Lakehouse perspective as compared to things like Presto and Trino or the work that the Dremio folks are doing.
We chose Spark actually 2 years ago. Like at the time, like many people were surprised when we say there is a SQL functionality like in the Spark. Or like, really? Like maybe you should use Trino or Presto. But the problem with the Presto and Trino, they're more memory sensitive products. Like we have seen this, like even Athena, which is a AWS service backed by Presto, we have seen many times like when there is not enough memory, it just crash. And reliability wise, like we had always lots of problem with the Presto. And also like at the large scale, Presto performance like decrease compared to Spark. And the second reason is when you see, actually at the time like 2 years ago, like there is some signs, but like today it's very obvious. The support of this, like this asset platforms like Lakehouse platforms like Apache Iceberg, Hoodie, Delta Lake, they have their support first Apache Spark, then like Presto, Trino, and others. And the support that they provide to Spark and to the other platforms are not at the same level with the Spark. You can get better, integration in the ecosystem, Apache Spark. And also like it's been always like very there's huge development on the Spark, but lately in last 2-3 years, there's huge increase on like improving the Spark SQL functionality, especially the optimization rules. There are like huge changes there. Now I think we did some benchmarks. We see like huge improvements. Even though like we have a benchmark that ran 6 months before, there is 2 times improvements at least between Spark version 3.2 and Spark version 3.3. That's the reason we chose Spark. Yeah, I think that's still the right choice. But yeah, in general, we call Iomete as a data platform. Maybe in the future, if it's necessary for specific use cases, we could integrate Trino also. But Spark right now covering that too. Trino works good. They have more data integrations, and Spark also catching up and in that space.
And you mentioned a little bit of the investments that you're making into make it easier to be able to adopt Iomete. So you mentioned things like the DBT adapter, the work that you're doing with the Airbyte team to create an integration there. I'm wondering if you can talk to some of the ways that you think about the prioritization of which elements of the ecosystem to invest in to manage that kind of adoption curve and some of the signals that you're looking to be able to understand what are the biggest pain points or most important pieces to solve for early on to help your customers kind of manage that transition or manage the initial adoption.
We have got many customers through DBT ecosystem. They saw us on DBT page that they saw there's integration and there is like you provide good performance for the same value. For now, like our main focus for like mostly on the data ingestion side. Once we release Airbyte and Singer, we want to really focus on Fivetran because there are also many customers are coming with they're already using Fivetran. You try to make the migration as smooth as possible. That's why as a vendor, I want to say that, hey, you can keep using those vendors and just use us to replace Snowflake or something else. That's why having more integrations with the well-known vendors is important. Yeah, The Fivetran and Segment.io are the scheduled ones for us. That's very important. And yeah, I think for the BI side, we are good there because we have almost all the integrations, mostly in the ingestion side, I can say.
Data engineers don't enjoy writing, maintaining, and modifying ETL pipelines all day, every day, especially once they realized that 90% of all major data sources like Google Analytics, Salesforce, AdWords, Facebook, and spreadsheets are already available as plug-and-play connectors with reliable, intuitive SaaS solutions. Hivo Data is a highly reliable and intuitive data pipeline platform used by data engineers from over 40 countries to set up and run low-latency ELT pipelines with zero maintenance. Boasting more than 150 out-of-the-box connectors that can be set up in minutes, Hivo also allows you to monitor and control your pipelines. You get real-time data flow visibility with fail-safe mechanisms and alerts if anything breaks. Preload transformations and auto-schema mapping precisely control how data lands in your destination. Models and workflows to transform data for analytics, and reverse ETL capability to move the transformed data back to your business software to inspire timely action. All of this, plus its transparent pricing and 24/7 live support, makes it consistently voted by users as the leader in the data pipeline category on review platforms like G2. Go to dataengineeringpodcast.com/HevoData today and sign up for a free 14-day trial that also comes with 24/7 support. As far as building a platform that is targeting this ecosystem of the kind of core storage and querying and processing layer that is the most important or most impactful choice that can be made for a data platform, I'm wondering what have been some of the most interesting or challenging aspects of building an entrant into that space, figuring out what are the kind of competitive advantages that you're looking to offer, how to talk to customers to help them understand what that competitive landscape looks like, and also to the point of what you were saying earlier of building on these open source systems so that you don't have vendor lock-in, just how to communicate with customers about that fact as well.
Interestingly, like many times when we get this, like first customer interview, they do better pitch than us. Like, because, like they saw all this and like many times we heard this saying like, this all sounds too good to be true. Do you really like provide all this? We are getting a lot of Snowflake customers, by the way, like not Snowflake customers, like who are already tried Snowflake or like they did due diligence or like they were considering Snowflake. But, like I can give one example. One of the customers, it's a big payment customer. They had a big like 100K credits for Snowflake, but once after moving 5% of their data, they just realized it's going to be very expensive. And they started looking for alternative, like, like not to replace this, maybe use some other technology next to Snowflake because they cannot put all their data to Snowflake. And they're looking for Databricks or like a similar solution like Iomete. That's why I think people really appreciate the cost aspect first. The second is like they're happy with like storing the data on their side because, like we didn't build this just, like we just assumed that people need it. We saw as a user, we saw that like, our managers were asking that, and we saw in many different companies that's the need. Like people want their data accessible. It shouldn't be somewhere else. And we hear the same, pitch from the customers. They're really happy like to own their data. And like we also give this message with that. Hey, you own data. You can go anytime. The only way we look into our platform is providing better service. There is no other way. Like you can just stop the account, the cross account access, and you can go, like to different vendor with their data. Yeah, I think first is the cost part. The second, having their data controlled by them or accessible by them is very appreciated by the customers.
Another interesting aspect of the Lakehouse paradigm is that It's intended to draw on the benefits of both the data lake and the data warehouse. The data lake is often seen as a place to be able to experiment with data, work with it, figure out what are the pieces that I actually want to use so that I can clean it up and model it into a more kind of data warehouse style, or load that into maybe an OLAP store so that I can get faster interactivity with it. And with the Lakehouse architecture, I'm wondering what you see as the realities of people actually going that next step of saying, okay, I've got it in the data lake, I'm able to use the warehouse for the modeling, but I actually need to also use this data in another avenue where maybe I need faster query times, or maybe I need to load this into another operational system, and just some of the realities of how people are actually using the data that originates and is owned by the Lakehouse and feeding that into some of these other types of systems.
That's the usual pattern that people use. Like they move the data to Lakehouse and they do the aggregation, cleanup, transformation, and then write back to some other platforms like HubSpot, or they can write back to MySQL or like other databases for fast access. But I want to just give some clarification. Like, what's the difference between data lake and Lakehouse? Because these two terms are being used interchangeably, but there's a difference there. Data lake got popular with the storage and compute decoupling because that allows people to scale those resources separately. And you can even shut down your compute cluster, scale out, scale down. You can even create multiple clusters to isolate different teams or different use cases. But data lake has problems that you have to deal with the files. There's with the metadata, you have this table abstraction, but if you want to provide column level authorization, you cannot give that authorization. You have to give not even table level authorization. You have to give file level authorization. This person has access to file, yes, then he can get the access to the table. You cannot do transactional inserts. You cannot do update, delete, merge stuff. You have to do all this stuff with some additional scripting tools, etc. With the all good benefits, people started missing out the good parts of data, all traditional data warehouses like table level abstraction, inserts, update, deletes, transactional changes. So the Lakehouse is basically the same data lake. It's what's running behind the scene, but there's additional layer that goes on top of the data lake that makes it present this as a data warehouse to the outside world. Now it becomes, you don't need to deal with the files. This Lakehouse layer handle that. There's acidity comes into the picture. You have this insert, update, delete, merge, all this functionality. Even in a transactional way, you have your version history. You can go do time travel in your data versions. All these things brought by the Lakehouse layer, this additional layer. So that's the difference between data lake and Lakehouse. And with that change, I think the need that you have to bring your data to more, you have more flexibility here. The need of using two different systems fading away. They're mostly staying in the Lakehouse. They don't need any other OLAP database. They can do all this in the Lakehouse. But for specific use cases, if you need sub-second latency, you can write back the aggregated data to MySQL or Postgres data, and then your ML systems or AI systems can utilize that data, which is a kind of aggregated form of your data from the Lakehouse.
In your experience of building Iomete and working with your customers and integrating with this ecosystem, what are some of the most interesting or innovative or unexpected ways that you've seen your platform used?
Yeah, usually we didn't have such cases. People are, mostly it's data engineers. They are really know what they're doing. That interesting case we got once, we got bug report that the result grid from SQL editor, it just got freeze. Once we checked the situation, it was 1,700 columns that table has. We were completely missed that kind of situations. But, in the analytics world, having like a large number of columns are usual. But even I wasn't expecting that number of columns that we can get from any table. Yeah, sometimes we got some customers, they were asking, like, do you have a fling? Can we? And basically, when they explain their situation, it's basically more operational use case than analytics. In that case, I recommend them like going a different vendor or different path, because the system is designed for analytics use cases, not operational. But that's something for the future that we should think, like that area is also being consolidated. Like they want to use one platform for analytics and even operational, but like has some analytics aspects in that use cases.
In your work of building the platform and building the business, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I'm not sure like if I can be a second time founder, because like if I knew like it's going to be this hard, probably I wouldn't start. Like I was told that building a business is very hard, but like I didn't know that I need to multiply that hard to like 1,000 times. It's going to be that hard. Yeah, it's just that I didn't knew, but there's also like the parts that I didn't knew, that there is huge intellectual satisfaction, like as you build stuff that helps to other people. When you see that results, like you forget about all the hard moments that you have. But yeah, I think it's kind of fun. It depends from which perspective you're looking at. But I understood it's not for everyone. I lost a few of my friends along the journey because they couldn't handle that. And I totally understand. Before I was thinking, like everyone can, like start a business. But now I understand it's not for everyone. It requires really tough mental energy. Yeah, that's something I learned. But I think I enjoy the process. I like it.
And so, for people who are interested in building their data platform, they think that a data lakehouse is the right approach. What are the cases where Iomete is the wrong choice?
I think like sometimes if it's not analytics use case, like more operational use cases, we are not good fit. Also, like in some cases, they're looking for sub-second or, like really low latency use cases. Iomete is not the right choice. Not even Iomete, like the similar technologies like Presto, Trino, Databricks, Snowflake is not the right choice in that kind of situations.
And as you continue to build and iterate on the Iomete product, what are some of the things you have planned for the near to medium term, or any particular problem areas or projects that you're excited to dig into?
For the coming few years, first to kind of like complete our vision to provide all-in-one platform, like without going to 3 to 5 different vendors, like spending time with the integration. They can get everything in one platform at affordable cost. That's our dream, like, and like kind of go-to platform for anyone who cares the cost. And the another milestone is becoming not only the platform, also the smart platform. I can give an example on the SQL editor, not just like, like only out IntelliSense. We want to also provide smart suggestions. Hey, when you write query, you can get suggested by the editor that, hey, this table is joined by these tables. You can use these columns. They're like this kind of stuff. Like we have data governance. We kind of collect this metadata. We also want to use this, not just sit down there. We want to use like this as actively, like not just metadata shouldn't be something that you only see when you go and search it, but it should help in different places. As I said, like in the queries, it can suggest, hey, this is wrong column. It might be wrong column that you are joining using in the join, or like it can use the glossary to suggest some additional stuff. In the data governance side, like it's maintaining of data assets is a hard thing. Like it requires a lot of user input, but you can imagine you have a like intelligent assistant next to you who knows the all ins and outs of the data and suggest you some stuff. Hey, what about this data? It seems it's not being refreshed last few hours. There might be a problem. Or like, hey, I suggest this text for these columns. We did this, by the way. Like we built machine learning / regex type of engine, which kind of scans data and then put out auto suggested text. But we want to bring it to the next level. Anyway, like the goal is not to just provide a platform, also like kind of smart platform. Whoever use the platform, they should feel there is also another one constantly assisting them the process.
Are there any other aspects of the work that you're doing at Iomete or the overall ecosystem around lakehouses and that architecture paradigm that we didn't discuss yet that you'd like to cover before we close out the show?
In my opinion, data sharing is going to be, like a thing for the future, especially all these platforms. Like Snowflake has something, Data Lake, Databricks built platform in the data lake. There is a data mesh is coming in the future. We don't announce ourselves as a like data mesh because like it's now buzzword, but we do like care the architecture when we build that's compatible with the data mesh approach, which is not new. Like when I work at Uber, like everything built like exactly data mesh architecture explained, but we didn't just call it data mesh. That's the only difference. So like I use a lot of my experience from Uber when we build this platform. That means we're going to be also compatible with the data mesh architecture. Many companies still like they're missing the centralized data platform. They're still to catch up that phase. But the next phase most likely is the data mesh, which is, solving not infrastructural problem, it's more organizational problems. It's the same way that microservices solved, like which brought some problems while solving some other problems. For the people who want to consumer data mesh, I would suggest don't consider until you have the organizational problem because it's costly. It solves the organizational problems, but it's costly. That's why, like, if you can live with the centralized data storage approach, I think that's the way to go. But once you hit like this organizational problems, you want to like separate different organizations and then like treat them as a different domains, then yeah, that's where you have to think about data mesh. Yeah, we provide all the functionality that data mesh architecture requires. It's just, like we haven't started announcing ourselves. Like Trino is advertising themselves as a data mesh solution. I think it's a small part of it, not just like I don't understand why they're advertising them like as a kind of whole solution for data mesh. And also back to data sharing part, and that's also going to be very important as a part of this data mesh because data mesh is making the boundaries and then like creating a protocol for data sharing. And so far there is no such, like easy protocol for data sharing. Like data like bring their own protocol. Snowflake has its own protocol, but probably we need to have something like HTTP for data. That's something like we do like our research, like probably soon we can also bring something on that space too.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, the biggest gap is I think like having multiple vendors for the, like standard data platform. I think all this should be in one place. Shouldn't be 3 to 5 different vendors. But separately, there are good tools out there. I'm not talking about the cost aspect, but yeah, there are good tools in its like specific area. But the missing part is having everything in one place, unified experience as a unified experience.
Absolutely. Well, thank you very much for taking the time today to join me and share the work that you're doing at Iomete. It's definitely a very interesting platform. Definitely excited to see that out there as an option for people who want to build their own lake houses. So appreciate all the time and energy that you and your team are putting into that. And I hope you enjoy the rest of your day.
Thanks a lot again. Thanks for having me here. I enjoyed the process. I enjoyed the conversation.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.